Welcome to Season 13 of the Prosthetics and Orthotics podcast. This is where we connect with experts in the field, patients who use these devices, physical therapists, and the vendors who help bring it all together. Our mission remains the same: to share stories, tips, and insights that help improve patient outcomes. Tune in and join the conversation. We're glad you're here and hope it's the highlight of your day.
Hello, everyone. My name is Joris Peels, and this is another edition of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
Hey, Joris, I'm doing well, man. I was at Rapid this past week, and it was fun to kind of text you back and forth. But it was a pretty cool venue, and man, it's actually a lot of stuff. So,
So what did you see? What impressed you?
So what impressed me? So you had sent me a couple things to go check out, and I did check them out. So that company Ripali for the vapor polishing, I don't know how you found them or knew about them or whatever, but that is legit. They do not use heat in the process, and that is very, very cool. And the price point is also on point. So, and the way that they can do small, thin wall parts is pretty amazing. So I'd love to hear your scoop on the pulse of that.
No, I think I've always been So, just for the people that are uninitiated, a lot of parts need to be smoothed. Part of that is just like layers. We don't like the layers, right? And part of that is just basically for a more consumer feeling product or consumer level products. People expect certain looks and feels, and you want to recreate them. And part of it is just like for a lot of medical stuff, maybe you want, you don't want a dust buildup or something like that. So there's there's mechanical polishing, basically stones in a turning thing, or you can have vapor smoothing, which is a very exciting process. Also, I almost killed myself doing that once in my own house, which you should never do, by the way, as an aside. And vapor smoothing is kind of a magical process, and they all work a little bit differently. But essentially, the vapor is under some kind of pressure or heat or something, pumped into a chamber, and it eats the outer layer away. And sometimes it eats too much away, sometimes it eats too little away. Sometimes it's a relatively harmless alcohol solvent type of thing. Sometimes it's a PFAS chemical that will eat away all sorts of stuff and interfere with your reproductive health. So the key thing about vapor smoothing is to understand what it can do and what features it takes away. And also to understand what chemical is being used, because usually, sometimes these are really benign, and other times they can be super evil kind of stuff. So it's a really exciting process if we're really going to that consumer level, consumer fit. And you had companies like Dimension, you had other AMT, other companies doing this, and now we've got a Chinese player. Oh yeah, Luxyours also did this, and then we have a Chinese player hoping to kind of shake this up, and then. So I was really curious how the part. I'd never seen the parts for real and stuff. So I was really curious to see. What did you see? Were you impressed by the parts and the setup and everything?
Unbelievable, yeah. And I think what impressed me was the thin wall parts and anything with like through holes. Typical vapor polishing with the heat, you don't get much past kind of the visual line of sight of what you see. But with this part, he had like this long tube with probably a 5 millimeter, maybe even a little bit less of an orifice, and as far as I could tell, it was smooth all the way through, which is unbelievable. So yeah,
that's super exciting. I think it was inspired more or less by Luxyours or something. That's a similar kind of technology, and they do smoothing with pumping different chambers of different densities and different chambers in different orders. So that gives you a bit of a more complex recipe to get that done. So but I think that's really good if you really want to get to smooth parts. It's a really exciting thing to see competition there. Anything else you saw that you really, really liked or didn't like or something like that?
Well, I do have a funny story for you. So about 2 weeks before the show, HP was touting, they're going to be releasing something new, that sort of thing. And so I think I told you that I bit the AI bug pretty hard. So I had my OpenClaw server and I said, what would HP be releasing? And it scrubbed like Reddit, YouTube, any social medias, all that stuff. And it said, they're going to be releasing a small machine.
Really?
Yep.
Okay.
And lo and behold, they released a small machine.
Well, I'm being put out of the work, and you think that's funny. This is not good.
Well, there was a leak somewhere for sure for the AI to pick that up. Nonetheless, I mean, I think most people said that, it's kind of the obvious that they need to go to a smaller machine, especially with the 580 out. And, I would say it's neat, but it's small now. And it's still going to be tough. It's 2027 release date, PA 12 only.
Mm-hmm.
It has a Form Labs-ish look to it, even down to some of the containerizing things. There's a lot that could happen between now and 2027. And at 60,000,
I did see that. Yeah, okay, that's a good point. That you're saying they're releasing it now. They give us the specs, and you think maybe somebody will sneak in there or something like that.
Well, you never want to be tied in, and it's kind of like the Form Labs when they said that they were going to be releasing the Fuse at a $10,000 price point, and then it comes out and it's 25,000 plus all the accessories, and you're pushing 60. If HP is saying 60,000 now, it's a pretty aggressive target to say that you're still going to be at that point in a year and a half.
First, about the 1200. This is an entry level 60K LPBF machine. We would love for the O&P market to have PI11, obviously, but or open material or stuff like that. What do you think? Do you think if they stick to that price, and if it kind of says what it does on the tin, do you think this is going to be a real contender for O&P clinics? Like the individual clinic is saying, "Hey, I'm going to drop 60K in this shit, this thing, and then I'm going to make stuff in house." Or is then the build volume too small, and you think it maybe won't work?
Yeah, I think you've got to take a look at what the consumable costs and all that stuff. But you are
$100 a kilo, 80% recycled, or max 80% recycled. Probably 60 is probably more likely.
Yeah,
that's kind of what we're looking at.
Yeah, I would say if the build volume is so small for the O&P market, and we know that the polyamides are not great when you open up the sockets for like adjustable sockets and that sort of thing. I think that there's just too much potential for failure just from what we know about the PA12. Now, if they include the PA11, I think that gets interesting. I think it's also interesting for upper extremity prostheses. So any of the arms, braces, that sort of thing. So, and I think that there's a lot of opportunity with the idea of fusing agent, detailing agent, kind of like what they've showed with the dual tone stuff, like a grayscale that can be put on via detailing agent.
I thought that was showcase that now. Yeah, okay, that's good.
Yeah, so I think that's interesting. It's tough when you're PA12 only. I just don't think it's the right material for O&P, but I'm just one guy. So anyway, but nonetheless, it was a neat, and everybody was very excited. But they had some other things going on too with that dual tone and stuff that I think is more exciting. And as long as I what I do appreciate is they see the value of a lower cost, smaller machine, because the reality is most people are doing small parts. They're not doing these massive parts. You're talking about fasteners and other little things, that body clips and things of that nature on the industrial side. And I think that it is very compelling gateway drug, so to speak, to the powder bed fusion world.
Yeah, totally. I think they're really focused on cost per part. We all know that kind of on the secondary cost of HP can be very high, but on the front end, if you will, they're really focused on bringing down cost per part. And I think that's very laudable of them to do that and smart. Anything else you saw that you thought was really cool?
Well, I think that the metal stuff was interesting. The one thing, and I showed you the card, and it was a LAPIS, is that right? Lapis.
Yeah, that's the
very
coolest
cool.
Thing I've seen in a decade. Like seriously, I'm not kidding.
Their metal stuff and the way they do that and the tolerance that he was holding was unbelievable. And what was crazy is it was just a chance meeting. I was standing at a table and I pulled a Yoris Peel. I'm like, who are you? What do you do? Tell me more. And so we ended up having a really good conversation. I got his card and we'll be following up. But the technology is, instead of powders, they use foils, very thin foils, to kind of laminate a layer to layer. And through the magic of software and other things, they're really able to keep very nice tolerances. And when you don't have powder handling, that's pretty cool. And the build volume's small, but a lot of this stuff is the parts, that are interesting are small anyway. So I was super impressed. Anytime that you see that stuff and you get to put it in your hands, that's pretty awesome.
And so the Lapis process, it's a Singaporean research project. They're kind of in the commercializing and research stage, and the foil is $5 a kilo or something like that, $5 to $10 a kilo. So it's really cheap, and they laser ablate it, so they actually get really good surfaces and really good sides on it, and the parts look spectacular. And it's just spectacular and super cheap for small parts. We don't know where that's going to find a market, but I think it's really, really, really is one of the most amazing things I've seen for years. So I really, really like Lapis. I like them a lot. Okay, cool.
Yeah.
Anything else?
I would say that's the bigger one. I mean, I think that there was reinforced 3D was very cool. I don't know. It's a pretty pricey technology, but I understand that there's a lot going on there, and it's something that is needed for these thermoplastics. And the reinforced 3D is for lack of a better term, it's a fiber and resins that can be injected almost like with a caulking gun into channels to reinforce specific areas of your print. And it is unbelievable, for sure. I think the pricing makes it difficult, but for those that are in like the UAV space and other things, I think it might be interesting. For the prosthetic and orthotic space, while it's interesting, I think it's definitely kind of priced out of the market there.
Yeah. What were we worried about? Like the materials price or the system? Is the system too expensive, do you think?
Yeah, the system is pretty pricey. I mean, my understanding was somewhere, 150K-ish.
Mm-hmm.
And it's one of those things that you just have to be super careful and intentional as well, which, we're not a big job house right now. So it's one of those things where you want to have a bunch of those jobs lined up. And this might be something that you do at the end of the day where you're just running this machine nonstop for a couple hours, filling all the voids. It's super cool. It's a very, very cool technology. And I would love to have one. I can tell you that. But the price point right now for me is just a little bit high. Now, if I had a job come across my desk, that there probably is something that would pay for that. And I think that would be, it's very cool. Very cool.
And I think by injecting these cavities after the fact, you can get like really different design things. And I think, I wouldn't really imagine that it would really suit like somebody taking lots of different jobs. But imagine somebody making like one of these more athletic related devices or something like that. Just one little hinge part or one kind of really structural part, a tube-like part. That could, just series production of that part in different sizes. Something like that could be really, really nice. Or bikes or, stuff like that. If you do series of things, I think it could be in carbon fiber. I think it could be really exciting. But yeah, you're right. It's one of these technologies where it's like, it's so great, but who's actually going to stomp down and invest in it? That's always going to be their problem, I think, because it's also really new. So that never helps, right?
Yeah. Yeah.
Okay.
So, and then rapid liquid print was very cool to see. They had the machine there, and as you know, I do some liners with them, and I got to talk with the main people there and talk about how we've been improving our process along the way, along with them and communication. So that was very cool.
Yeah, I love rapid liquid print. MIT startup. They're extruding silicone into like a hydrogel type material that is right balance. So it's kind of like a hair gel kind of thing. And basically, it acts as a support. So they can make really freestanding structures relatively cheaply. They're a beautifully made machine, also, that has to be said. I love the team. Shendy and all these guys are really, really nice. And I really, really like what they're doing. And they're really making elastomeric parts durable. And perhaps even that's a system where there's other silicone technology, but then taking either it's not freeform enough or taking it in-house would just be really complicated and expensive. This is something maybe that you could buy that machine and you could actually make money off of it. I think eventually, if you had enough of like one family of product, I think and I really love what they're doing. I think they're a really great team as well.
Super impressed with their team.
Yeah, totally cool. And okay, so we have a long-suffering guest.
Yeah, so we have Alex Dahinten with us today, and I've known Alex for a long time, and it's been really neat to kind of see his trajectory. And we've actually shared a little bit about the company that he now works for, so I'm hoping to get into that. But nonetheless, I want to also hear about his journey into the O&P space. And one of the things that I think is inspiring is you and I say it all the time, is it's amazing how people get into the space and really how everybody's story is a little bit different and their journey is a little bit different. And I think that's one of the things that makes our space very, very interesting, and definitely having the right people with passion in the field as well. So I'm excited to hop into all that as well.
Cool. And then, yeah, the most common modalities are either did your parents do it or do you like to work with your hands and didn't you know what you were doing? Welcome to the show. And Alex, tell us, how did you get involved with OMP?
Well, thanks for having me. I've been a fan of the show, and I'm kind of pinching myself a little bit that I'm on it now. So this is really exciting. I got into it from an engineer's perspective. So I went to school for biomedical engineering and then started a career in kind of the developing world, middle income, low income country environments, and how to provide medical technology and build hospital capacity around medical technology in those spaces. Worked for nonprofits, and then most of that time I spent at Duke University working in the Developing Healthcare Technologies Lab under Dr. Malkin. It really grew my my ability to, or my awareness for how technology could be deployed in an appropriate manner in these environments that are often resource limited. Through that work, I did do some works at prosthetic clinics, mainly surrounding inventories and how to keep track of equipment and tools. And it started just becoming more and more interesting. I started seeing how I could use my skills, my artistic background, but also my engineering knowledge and my desire to work with people kind of on a one-on-one basis. And it kind of combined all of those things together. So I started looking into a little bit deeper. I was living in North Carolina at the time. I came back, asked my boss, it's like, hey, if I would go down to 4 days a week and maybe shadow this prosthetic clinic 1 day a week, would that be okay? He's like, sure, but I'll only pay you for 4 days out of the week. I'm like, deal. So that's what kind of got me into it. And then once you're in a clinic, once you're surrounded by passionate clinicians and working with patients and kind of seeing that, it's hard to go back. So decided to go back to school, get a master's, and here we are.
Okay, that was really cool. Coming from we've always had this idea that a lot of like people in OMP do things kind of on feel, or it's like not with FEA and stuff like this. And coming from doing the biomedical stuff first, did you find that weird, or was that a very different approach you had than, like, for example, as fellow students or practitioners?
Somewhat. I will say I was almost like an outlier, maybe in the engineering world, where I did go off feel, and I always wanted to approach a problem not just from a pure mathematical perspective, but also from a user perspective. And how does this feel? How does, when we design something, how does it, what are the ergonomics of it? What is the overall experience of the person? So I did enjoy that side of the engineering, which translated really well into the prosthetic side. But yeah, there are some things where I'm like, how are we not quantifying this? How are we saying that this is better than something else when we don't have any data to back it up? So that definitely lingered for a while.
And where did you kind of, like, what did you specialize in anything? Did you try to go really broad? What did you try to do when you were trying to like set yourself up for a career in the field?
Yeah, so I started at prosthetic heavy clinics. So I was mainly working with the prosthetic side rather than necessarily the orthotic side. Later in my career, I did work more on the custom orthotic side. I'd say most of what I've worked on has been lower limb kind of prosthetic designs. But then at one of the clinics I worked at, we started seeing just a lot more upper limb users come in and patients. I think, like most people, they find themselves just kind of catapulted into that role unexpectedly. And then there comes a moment of a little bit of figuring out, a little bit of, oh, shoot, where do I go from here? I don't really know what I'm doing. And then you lean on your community and the people around you and people who have been doing it for years. So I wouldn't consider myself an upper limb specialist, but I started seeing more and more upper limb as well during a period of my career.
And is there, like, did you make the right choice? Or you're like, oh my God, no, I should have never have done this. What did you like? Or do you see a certain person gravitate toward upper or lower, or is it just really circumstance dependent, do you think?
No, I think I've seen more engineers maybe gravitate towards the upper. It is a little more hands-on as far as the electronics of it and kind of the problem solving. You're working with technology and how the technology communicates with each other on maybe a deeper level than a lot of the lower limb solutions out there are there right now, at least. So I do see more of an engineer mind gravitate towards that upper limb. But yeah, a lot of kind of overlap between the services that you're providing. I will say for an upper limb, while you do have more of that technology focus, it's also a really intimate experience where you're working long term for long hours, especially at a time with a patient. I feel like a lot more things go wrong. And you're setting expectations in a way that maybe for lower limb you don't have to set as strictly, because things will go wrong no matter what. So you're making sure that the patient understands that, and they're kind of part of that process from the beginning.
I'm going to go on a limb here and say that like the upper thing is more like a systems integrator type of approach, and then the lower limb people are more of a craft type of approach. But that's also really like super generalized, so maybe it doesn't even make sense. I think maybe.
Yeah, I could see that. The craft is there no matter what, right? We're working with the very dynamic human body, and in some ways are using static principles to try to work with that. That also is kind of a transition to what I'm doing now and what I've experienced over the career, seeing the need for adjustable, flexible, malleable solutions that accommodates the patients as they change throughout the day, or as their muscles move and fire throughout the day. So those are things that I think are common to both of those industries. I think the craft and the art and the problem solving is definitely in both. I think with upper limb, you're probably maybe utilizing that in a more mechanical, electronic focused, maybe more of an engineering mindset though.
So Joris, I think it's a pretty interesting way that you describe it as kind of a systems integrator for the upper extremity. And while the craft is definitely there for making sure the socket fits and such, it does become a system. We've got all these hands, and we've talked about that before, and then the pattern recognition and different bioelectric signals, computers, wrist units, that sort of thing. And so you have to know a lot about how this stuff kind of goes together, and truly getting everything to talk to each other as well as a systems integrator. And then the lower extremity stuff, I think you're right as well, is this is a weight-bearing surface. It is it is very technical. There's still a lot of things to do, but not the electronics that you have with some of the other stuff, other than, say the microprocessor needs and such, which are always great. Now, yeah, so I love that.
Does one of the two make more money than the other? I'm just curious. I don't know.
So the upper extremity, the numbers are bigger, but your cost of goods is also very large. So when you look at the spread of, for lack of a better term, the profitability side of things, when you look at it as a percentage wise, upper extremity, while the numbers are big, would not be as percentage profitable as, say, lower extremity prosthesis. And the follow-ups, especially on some of these myoelectric arms, and you're dealing with small wires, and there's just a bunch of things that can go wrong. So there's a significant amount of follow-ups that I would say that are involved with upper extremity that you don't necessarily have with the lower extremity because of the technology that's used. Now, when you talk about the actual number that goes into your bank account, the profit, that number can be good, but it's one of those things where, especially with the U.S. insurance market, you definitely don't want to be over leveraged, because insurance companies you are guilty until proven innocent. And so they can take their money back, and then you have to go prove that you indeed did provide the stuff. So you don't want to be super leveraged on your cost of goods when you're delivering these things as well. So it's a risk reward. And I will say that there are some companies that just do upper extremity, and they're really good at doing it, and they have a good billing department, and they have a very good track record, and that works. But it's still risky. It's just a matter of how much risk do you want to take. It's compared to the lower extremity stuff. And you're much more likely to get audited on high ticket items as well. So these are things that you just have to have all your ducks in a row, ready to rock and roll.
Another interesting difference between the two is it'd be really hard to kind of exist on an island, if you will, as an upper extremity provider. You've got to lean on your community, whether that's the clinical specialists, whether that's other clinicians. You've got to use that expertise and those mistakes that others have made and can kind of teach you about, Whereas in lower extremity, I feel like for the most part, once you've seen a few different presentations, you have an idea of what you're approaching. It's always going to be a challenge, and it's always different and unique. But in upper, it's just on a whole different level. And there's people out there, and that community is willing to share. That's the other thing I've found, is that upper limb specialist does not live on an island, and you can reach out and you can talk to people in a way that's really welcoming and builds an awesome community around patient care and getting better outcomes.
And I think one thing is interesting, like, because you worked before in these emerging markets or developing nations or stuff, delivering like other medical stuff. How do you feel about how good the industry is at delivering medical care or prosthetics, essentially, in medical care to, less privileged places, let's say, poorer countries? What's your perspective on that?
At the core, it's well-intentioned, right? I don't think anyone goes in and has ill will, ill intentions. People want to help the people that need the help. I'd say one thing that I have learned over time, and this is even before prosthetics, is your ability to capacity build that predicts the long-term success of and the number of patients that you can build in a region like that. So one thing that we really concentrated on is we would partner oftentimes with big corporations and industries that maybe even had a long-term interest in certain areas where, in that case, medical technology wasn't as well developed, because you're building the infrastructure and the ability for those countries and people to purchase in the future, even though that might not be there now, by building that network. So in our case, we collaborated really closely with the GE Foundation, who long-term saw many of these countries as future customers. But the way they approached it through us was we collaborated with technical schools, ministries of health. We educated local technicians on how to repair, maintain, and set up infrastructure at these hospitals to accommodate medical technology that wasn't available necessarily widely at the time. And then slowly over time, once you have the capacity to maintain, provide, and really set the foundation for that to exist, now you're working with the ministries of health, see a lot more opportunity and a lot more benefit to investing in these projects. And we saw it just explode exponentially. Our role there too, I'll say, was to educate these groups and eventually hand over to the local, again, technical schools, ministries of health, whoever was managing it in those countries, whoever was the right partner. And then we would stay for about 5 years, monitor, evaluate those programs, make sure they were effectively running, and then give a big hug, high five, and move on to the next region or next country and build the capacity there, because we evaluated that it was sustainable long-term. I would love to see something like that, or some of that thinking implemented a little bit more in the prosthetics market and industry, rather than what we see a lot of times is treating individuals and giving them access to a leg or an arm, if you will, but then maybe not thinking big picture, what happens long-term as far as taking care of them and also others in the future.
I know, I like that, because it dovetails really nicely with like Brent, who's always like, when you hear about, when he comes back from Guatemala, you hear him about, like, we did this many procedures, but he's most proud. I think you are. I don't know. Correct me if I'm wrong, but you seem much more proud of, like, it's actually, we trained this person. He can do it now, or she can do it now, and that seems to be like much more like what you're really excited about long term, right?
Yeah, and it's hard, right? Because prosthetics is built around these consumables and these liners and sleeves and socks that wear out and they break, and how do you not only build the capacity to provide them and design a prosthesis, but then also have access to the components? And how do you, at the same time, the same conversation also involves how do you build the fabrication and the manufacturing, either in the country or in the region, to accommodate that at a price point which is realistic for what the market is.
Yeah, and for me, I mean, the biggest thing is support. I mean, I think COVID pretty much exposed almost all NGOs that did not have a local presence, and so, I mean, it was, some of these countries were closed for literally years. I mean, a year or two. I know Guatemala, it was a year and a half before we went back. But I mean, I think one of the things that we loved is there was a well-stocked lab and a young man down there that took care of the patients during these times, made new prostheses, and that's the way it should be. But when you take a look at flights and hotels and food and all that stuff, and you have, say, a large group go somewhere, you take a look at that, and if you take that same amount of money and you invest it into a local talent or supplies, it really would go a long way. And I think a lot of NGOs would benefit thinking about that in that way.
Yeah, I early on in my career, when I was, again, still in medical equipment, we ran student programs where American, European students would come to Tanzania, they'd come to Honduras, they'd come to Rwanda, and we would partner them up with local students, and they would information share, they would learn about medical equipment, how to repair it, all those things. But one of the conversations I had with them early on as well was, don't overlook what you're getting out of this as well. And if you just come here and the priority is to, we fit a couple patients or we fixed a little bit of equipment and made a minor impact, that has value. But if you can take that mindset and you can take the culture and you can take the connections you made and the things that you saw and maybe some ideas on how to improve it in the future, if you can take that back with you, that's powerful in itself and shouldn't be overlooked. So I think that's really where those types of experiences can have an impact. We see it across the board. We see students that go, that all of a sudden their minds are opened and they maybe pivot their career slightly to something that they saw, which they're passionate about. That's an important, I think, part of these that I hope people going on these trips, especially if they're kind of once or twice in their career, that they can internalize and take with them for the rest of their career.
Yeah, I think one of the other things, Alex, and I'd love for you to share on this. I mean, you touched on it a little bit, glossed over it because it was kind of a normal thing for you, but this idea of compliant prostheses that move with you, I just wanted to hear your kind of take or philosophy on what a prosthesis is, especially after hearing you kind of describe it that way.
Yeah. So at its core, really, we've got something that is that's a moving target constantly, right? The limb that's no longer there, we're trying to replace that with things that are in its core very static and not at all really not at all really great things to replace all the complexity of the human body. And we try to get as close as we can. At its core, there's the technology is great, all the electronics and all the microprocessors that we have access to now. But really, at its core, it's how the interface and how the socket interacts with the human portion, the residual limb. And improving that has been something that I've been passionate about and kind of sought out in my career, whether that's employers, whether that's on the side, just learning more about how the body moves and how we could use materials to replicate that. And I just keep going back to the socket and how the socket is the middle ground or the part that translates what the mind and what the human body wants to do into these static components that need to be told what to do. And if that connection isn't strong and isn't comfortable and isn't compliant to some degree, then it's not going to be the kind of outcome that we're hoping for.
Yeah, well, I mean, I think the compliance side of things is so important. And when you take a look at the history of where that came from, even in the early or late 1800s, early 1900s, people were trying to get these flexible and did it through a myriad of ways in the patents, at least that I saw. So I think that's a really great take. And I think that's pretty exciting with the way materials are going with the way now, you've got something like a rapid liquid print, some of the nitro stuff that we do, some of the the adjustability, enhanced fabrics, 3D knitted fabrics. I think that there's a lot of things that is a wide open white space for prosthetics.
Yeah. What's really, what kind of the exciting and also the challenge in all of this is we want to make it like if we could strap a pillow to someone's leg, they'd love it, right? It's super, super comfortable, super compliant, but they'd fall every step because there needs to be some energy transfer, some way to transfer that energy effectively into the foot and into movement without sacrificing the comfort. And that's where you're constantly going back and forth, and in some ways maybe feeling like you're compromising because you need to achieve this other result. But it also opens up opportunities for us to continue to develop and problem solve and get better at it. And that's a really exciting part of the field.
And I think that's an interesting take. I think it's also really interesting, this idea, like just philosophically, is it like, what is the best prosthetic? Is it something that works with the leg or with the existing part of the leg or arm or whatever? Or is it something that replicates the functionality as it was? Or is it something that does the situation, that deals with that situation to the best ability? I remember we had a conversation about this with Brent a long time ago in the beginning of this podcast, where, well, sometimes the hook is actually kind of easier than some kind of super gidgy, super sophisticated robot in hand thing. What are your thoughts on this kind of like, what is the goal actually, like as a technological system? Is it something to integrate with the human? Is it a separate system?
Yeah, fortunately, we have so many different approaches nowadays where it's really up to us to understand what the goals are, right? What the patient wants to be able to achieve and how to translate that, and also how to communicate that in a way that they maybe had certain expectations coming in, which need to be slightly, slightly updated, if you will.
Yeah, okay. That makes sense. So talk us a little bit about what you're doing right now and where you work and what you're doing there.
Yeah, I joined Ethnocare. It's actually only been about a month, but I've known the guys for going on to about 2 years. So Ethnocare is a company based out of Montreal. And they had a really interesting start. It was started by 3 friends at university who were studying design. And they just come from a design background, an engineering design background. And one of their mothers, she underwent amputation about 12 or 13 years ago, bilateral transtibial amputee. And being such a personal story for Lewis, in this case, he started looking into that and he started seeing some of the challenges that she was having on a day-to-day basis with regards to her socket fit, with regards to stability, with regards to getting wounds, frustrations because she wasn't in control of her prosthesis as she may be with her shoes, right? You can change your shoes if they're uncomfortable. You can tighten the shoelaces if they're not fitting right. You can add a different insert to your shoes. But with her prosthesis, that was a little more challenging on a day-to-day basis. So they started looking into those issues and noticed that it wasn't just his mom that was having these issues. It was the wider community that was often expressing similar challenges. So they did something which I learned this recently. They looked into something called ethnographical research, which is also where the name comes from. And they really wanted to understand the prosthetic user, the population as a whole, their issues, behaviors, needs. And that was done in a qualitative manner. So it was done through interviews. It was done through conversation. And then these topics started to emerge where people were expressing the same frustrations. And that's where the name Ethnocare comes from that research that then is applied to healthcare and medicine and kind of the orthopedic solutions in general. But Ethnocare to me was really interesting because initially I thought it was kind of and we'll talk a little bit about the actual product, but it was more of a one product company. So I didn't see where things were going. And over time, I started to really understand it's not just about designing this one product and then coming up with a solution for a single issue. It's actually more of a platform to innovate for the prosthetic and orthopedic industry. So we're looking at, because they're engineers, I'm an engineer, we've got a great R&D team as well. That's actually fantastic. We're looking at these issues more from a design approach or an engineering approach, where we figure out what the problem is, figure out solutions for it, and then apply that to the users that we're calling for this. Rather than maybe some other approaches, which would be come up with the technology, come up with something new and innovative, and then try to find the industry that may apply to.
Yeah, I think this is like, an additive. We're a lot of companies get started just like we invented a box. Let's see what we can do with the box. So it's kind of a bit of a, the story is actually maybe just too familiar. It sounds like, if you say it, it's super obvious. Why doesn't everyone do that? But I think it's actually a lot of innovation, like user-led innovation. I think is a really, really important thing, especially for stuff you have to live with every day.
Right. And then the team that's assembled around this is really unique. They don't have an O&P background. I'm actually the first clinician or someone with an O&P background to join the team. So they're coming at this purely from a a design and here's a problem, what's the solution type perspective. The R&D director, he worked for CCM, designing helmets that need to be super snug and super tight because you don't want that movement inside of the helmet, but still comfortable enough to wear. So that's the approach that we're taking and applying that kind of thinking into the O&P industry.
That's super cool. And talk to us a little bit about your the product that you have right now, and then maybe some of the product. I don't know if you could talk about that, but the products you're going to come up with.
Sure. Yeah. So the product right now, kind of the flagship product, is called the Overlay, and it's a fabric sleeve that you pull over the liner, hence the name Overlay, and it's got an air bladder system built into it that the user can pump up or deflate as needed throughout the day. So we know one of the biggest issues, right, is that a prosthetic user, they're going to shrink down, they're going to swell up, depending on their condition, depending on what they eat, depending on if they have a beer for dinner or not, right? So we're constantly chasing that moving target. And typically, or historically, that approach has been using socks, where you take your prosthesis off, you put on another sock or take a sock off and then put it back on. And kind of, there's a little bit of hoping that it's going to fit just right. In this case, you're wearing the system inside of the socket. It's got a little manual pump at the top. Think like the old Reebok pump shoes. I don't know if you're familiar with those, but you kind of pump it up, and as soon as you feel the kind of sensation that you're looking for in the socket, then you go about your day. There's also a manual pump that each one of the manual pumps that's separate. Each one of the manual pumps is about 10 individual integrated pumps. So for users which do have a lot of volume fluctuation or change a lot throughout the day, carrying that around has been a time saver at the very least. The neat thing about the product too, which helps it really stand out against other solutions, is that it can accommodate volume fluctuations up to 15 sock ply. And that's kind of unheard of. When you're in 15 sock ply, chances are you're getting a new socket anyway. But I've had multiple fittings where patients have come in wearing 10, 12, 15 sock ply and put the system on, pump it up a few times, and take the pressure off those sore spots, are able to control their prosthesis a lot better and get by.
And this is one thing I'm interested in. Like, everybody's always saying that there's, like, it's super variable how, how much you fluctuate when whatever's going on, all that stuff. But once given the ability to pump up and deflate this thing at will, how often do people use this typically? Or there's like a huge range, or how does that work?
How often during the day?
Yeah, how often during the day? Or is there a typical number, or do you see that fluctuate? Or is it like, some people 3 and the other like 300, or what are we talking about here?
Pretty much. It's so individualized for the patient. I mean, you've got some patients who are on dialysis or taking diuretics, where they could, their limb shape, if you were to take a picture of their limb shape and hour 1 and then hour 2, you'd think it'd be a whole different person. And then there's others, so they're constantly kind of trying to find the right solution, the right fit during the day, so they're using it really quite frequently. And then there's others where maybe during activity, we see a lot of really active folks as well gravitate towards this, because they might just need a little bit of tightness on their run. They might just need a few little pumps to get a little bit tighter. And 30 minutes later, after they've sweat some and maybe find that their socket fit is starting to get a little bit looser, then they might pump it up another 1 or 2 times, but they're not seeing those major volume fluctuations. So it really is for both populations. Another thing that's really, really interesting that I learned that I wasn't aware of before getting into the space is the doffing effect. We see in the clinic, but we don't really quantify or look at systematically. We just kind of deal with. It's when a prosthetic user, when they take their prosthesis off, the research shows that within 5 minutes, their residual limb circumference or volume can change anywhere from 0.2% to 17%. So just by taking the pressure that was on their limb off, the body kind of resets, fluid rushes back into certain areas that maybe it was getting pumped out of previously. So now if you're extrapolating that thinking and applying that to socks, you're taking your prosthesis off, potentially changing the entire leg shape, and now trying to put it back into the same environment, either by adding or removing a sock. But you're you're changing the entire you're changing the limb shape and kind of the inputs, if you will, into the system. A really nice thing about this approach, and Ethnocare and the sleeve is by no means the only solution out there on the market. And it's not like everyone needs to be in this, right? There's different, the beauty in all of this is there's different solutions for different patients and preferences. That said, the benefit of having something where you're changing your fit and getting real-time feedback of how that modification changed how things feel is so important. You take your leg off. As clinicians, we've seen it time and time again. We educate patients on sock wear. We have them take their prosthesis off, add a 5-ply sock. They're like, nope, now it's too tight. So you take the prosthesis off again. You put on a 3-ply. It's like it's better, but still kind of loose. You take the prosthesis off. You put a 3-ply, and then you combine that with a 1-ply or a lightweight sock. So you're constantly trying to understand where you need to be without, it's almost like an unfair game that the amputees or the users have to play. So if you get that real-time feedback, you're like too loose, just right, and then you stop, and then you can, it's just a lot more intuitive and a lot more user-friendly, and really empowers the patient to take control of their prosthetic fit.
That sounds really cool. And then what are your things like, we talk about CAD and 3D printing and just like 3D design and scanning a lot. What are your thoughts on that? Is that going to change the industry completely, or do you see it just more of a prototyping tool, or what are your feelings on that?
We use it heavily for prototyping. As a company, where our goal is to come out with somewhere between 2 to 5 products every year, and there's so much in the woodworks, and we use it almost on a daily basis back in Montreal. I'm really, and you mentioned it earlier, I'm really interested and excited about the silicone printing, the project out of MIT. I kind of been observing that from the periphery. But that, I think, has huge applications in the field, especially when we talk about interfaces and being able to integrate that into these systems. I love it. I never got the opportunity. I could have obviously pursued it more heavily, maybe, but I never was at a clinic where we heavily had 3D printing integrated. But I was always curious about it, and I'm seeing all these great outcomes. So beyond having my personal printer at home, really, I personally haven't dabbled too much when it comes to using it for sockets or using it for other things in the industry beyond prototyping. But I think the opportunity is there, and it's definitely moving towards it.
And what are your feelings just generally about, we think about this a lot, about this industry where, there's so much going on in robotics, there's so much going on in electronics, chips, all that kind of stuff. What are your feelings on the industry, OMP colliding with that consumer electronics world and just the future of everything?
I mean, it's here, right? I mean, I was at the airport the other day, and I looked around me, and just everyone waiting for the plane was on their phones. So we're interconnected. We're constantly getting these inputs, and it's just natural for us to want to integrate that into our prosthetic design process. Because what gets overlooked a lot of times is maybe the patient experience is so first and foremost. But one thing we try to look at as well is what's the clinician's experience as far as fitting, as far as being able to obtain the device, and how can we make that easier using available technology, and how can we develop technology to make that easier for the user. One thing is our sizing. We have this really nifty kind of sizing tool on our website, which has really helped clinicians more accurately measure for patients. On the back end, we're using, I know the team has integrated AI into a lot of our internal processes. So I think that's another opportunity, not just for the actual prosthesis and the technology integrated into the prosthetic device, but actually for the processes that allow the clinician, the manufacturer, whoever it is, to get to that end product. I think that's really exciting as well.
So we know all the benefits of having the ability to adjust for volume changes for the patients and such. But this journey with Ethnocare for this sleeve has not been the easiest journey, right? There are some bumps along the way. I'm sure there was some coding stuff and all that. Can you just share a little bit about that journey? And it seems like now you guys are at a reasonable spot, probably not where you wanted to be, but a reasonable spot.
Yeah, that's it. And what a journey it's been. So when we designed this solution. You have the, like we talked about earlier, you have the problem, and then you design a solution for that. And now you have to get it out there into the market and make sure that people can actually access it. Typically at least in the US, what you want to have is you want to have some kind of a code that describes that system, an L code, right? That allows the clinician to, one, get paid for providing this service. And what that leads to is really just the patients getting access to this type of device. So initially, when we started in the US, it didn't have a code. So it was what you consider a 99 code or a miscellaneous code. Clinicians were getting really excited about this. Patients were asking for it. And it was really starting to gain traction. But because clinicians weren't necessarily guaranteed payment on it, it was considered maybe more of a niche device or more of one of those like, hey, this is a really challenging to fit patient. Maybe this could be a solution for them. Or this is, maybe a one-off where the patient really wants this, so I'm going to provide it to them. But it wasn't seen as like a global solution. As of April 1st, and it was no April Fool's joke, Medicare now, first of all, in about October of last year, they actually allocated a L code, the L5657, for this device. It's an addition to code that describes a device that uses air to accommodate volume fluctuations. And so with that code, however, they didn't allocate a fee schedule. So they didn't say, hey, if you build this code, we're going to pay you this and this much. Clinicians were billing MSRP and really sometimes getting paid, sometimes not. As of April 1st of this year, 2026, they did allocate a fee schedule towards it. So now clinicians can go into this with a lot more security, knowing that they're going to get paid for the services that they're providing and provide the service to the best of their abilities. Right? Because this is just like anything in prosthetics. You need to educate, you need to familiarize yourself with it. You need to problem solve. You need to change, adapt, and constantly be on your toes when you're providing these types of devices. But really at its core, the fee schedule has opened up a clinician's access to this technology and a patient's access to being able to utilize this as a really an everyday solution.
I think that's, man, what a journey. I can't imagine. And it's multi-year journey and the involvement of, getting the code and then not having the pricing quite right. And then finally getting that corrected to the best, potential outcome. I think that was a really good thing. And what I love is this is a great foundation for you guys to keep on going. Now, I mean, I don't think it can get any harder than this product. And now you guys kind of know the path forward if you're going to bring something innovative to the market that doesn't exist, which is always a risk, but there's a massive amount of white space for things that help patient outcomes, but people are scared to bring that to market. So I think that's one really cool thing about the company that you're working with is not, well, you always want to get paid, right? But it's, hey, these are things that will make patient outcomes much better and truly solving a solution and not looking at the L code. So it's the road less traveled for sure.
Yeah, and it's really a huge opportunity, and it's a really exciting time to join the company. I probably did it the wrong way because I joined them a week before Medicare actually announced that it was giving it a fee schedule and what this fee schedule was going to be. So for me personally, I believed so much in this product and knew that we were going to figure out a way of improving that access, whether it was with the fee schedule that we hoped for, whether it was, some way around that. But then my first week, I was actually in Montreal when they made the announcement, when they got back to us. So within that first week, it was really a sigh of relief in the end, because it could have gone a lot worse. Of course, you wish for it to be better. But overall, I think we're so excited to have, in a way, close that chapter and be able to move forward with that code and with the fee schedule and really seeing more and more patients have access to this technology.
Yeah, that's great news, Alex. And thank you so much for being here with us today here at the Prosthetics and Orthotics podcast.
Thank you, guys. It was a lot of fun.
And Brent, thank you for being here once again.
Yeah, this was great. And hearing Alex's journey, the journey of the company, and really pushing to get great outcomes for patients is very inspiring.
Totally. And thank you for listening to another episode of the Prosthetics and Orthotics podcast. Have a great day.